Acylation of benzene. Objective: to understand the Friedel-Crafts acylation of benzene. In chemistry, the process of adding an acyl group to a chemical compound is known as acylation. The Friedel-Crafts acylation was first discovered in 1877 by chemists Charles Friedel and James Crafts. The Friedel-Crafts acylation of benzene is the acylation of benzene with an acetyl chloride using a strong catalyst, which will be a Lewis acid. Let's look more carefully at the acylation of benzene with acetyl chloride. Acetyl chloride is an acid chloride which is also known as ethanol chloride or acyl chloride. The end product of the acylation of benzene with this acetyl chloride will be acetophenone hydrogen chloride. Because aluminium trichloride is an electron-deficient molecule, it will form only 3 bonds and has no lone pairs of electrons. That means there will be 6 electrons around the aluminium atom. Chlorine, in the form of a chloride ion from the acetyl chloride, will form a coordinate bond with aluminium chloride to yield an aluminium tetrachloride anion. Both electrons in the bond will come from the chlorine as it is removed from the acetyl chloride. The electrophilic substitution mechanism. As the acetyl chloride ion approaches the delocalized electrons in the benzene, the positive charge will attract the electrons. 2 electrons from the delocalized system will form a new bond with the acetyl chloride ion. With the moving away of the 2 electrons from the benzene ring, the delocalization is partially broken and the ring will gain a positive charge. The next step involves the addition of the carbocation to the aromatic system, giving a sigma complex, which loses a proton in the form of hydrogen to reconstitute the aromatic system. Now let's return to our aluminium tetrachloride anion. As the anion approaches the benzene ring, one of the aluminium to chlorine bonds will break, and the 2 electrons will join with the hydrogen. This will result in the hydrogen breaking away and joining the separated chlorine to form hydrogen chloride. In the process, the aluminium chloride catalyst will be regenerated. The electrons which held the hydrogen to the benzene ring will re-establish the delocalized system, and a ketone named acetophenone will be formed. Summary: the process of adding an acyl group to a chemical compound is known as acylation. During the acylation of benzene, an acyl group is substituted into the benzene ring to form acetophenone.